Hello and welcome. Today you're a brand new compiler demo. I haven't done one of these in a few months actually. I've kind of done a lot as well. So I've kind of tried to compactify all the new features and ideas I've put into the language. So hopefully it'll be a great idea. I'm going to go through about some of the new demonstration stuff in this code, and at the end, please, if you've got any questions, please just write my name in the Twitch chat with its ginger_bill, and then pose your question then. So great. And at the end, I've also got another question for you guys to ask. So let's get started with the demo. So let's start with the very first thing, which is some syntactical changes mainly. So this is a minor thing as well. The first thing I actually didn't demo off last time, but it works now properly, is I've got cyclic type checking. So if I go into here and build, it now says, hey, there's an illegal declaration cycle of A, and it says B refers to A. So it's great. So you got the errors there and it'll work. So cyclic type checking, great, and the errors are working. The internals is, when I was doing originally, I was doing it when you were defining the type, and I was checking the names as if they were defined that way. I found that you had to do a lot of memory allocations to do that, and it wasn't a very good method. So I've kind of postponed the cyclic type checking till the end of checking, and I check it then, and it's quite easy. So now we're going to talk about the casting style. Previously, I used the as notation. So the old style for casts were like x as f32. I've now changed this to the original style I had, which was the prefix thing here, which is the cast type expression. Works the same with transmute, and which is the bit cast. There's downcast, which is you go from the subtype to the base type, which is like object-oriented speaking, whatever. And you've also got the union cast, which is a type safe checking way to see if, hey, can I convert this union into one of the subtypes of the unions? That's some basic stuff. Other things is you've got some nice little basic directives like files, lines, and procedures, and I've also got fancy new printf, so it'll do some clever nonsense as well. So you do print S's in there, you can do V if you don't care what the type is. You could just write T if you wanted, if you want to print the actual type. So it will tell me now this is a string you passed in. It'll do loads of stuff for you. It's great, and you can see it here, basic directives, puts me the line of the code, and the procedure name, which is syntax. Hey, fine and simple. The only problem is I don't really have very accurate float printing, because that is actually very difficult to do. But, yeah, I'll leave that for another day, and that's a standard library thing. That's not really a language feature. Going over with these syntactical things. Again, records now are just using commas. This is so they are the same as procedure signatures. Is signatures the ML style word? But anyway, that's what I call it. So you can do it like inline, like a procedure, and that's one way of doing it. The other reason for doing this is it prevents you can do nesting within procedures. I originally allowed that, but I might bring it back. But I prefer this style actually because I can do nice inline structs, and they're just as easy to read in my opinion. Slices now, which are kind of like array references. Originally had them as pointer, account, and a capacity. I've got rid of the capacity part, so now they're just a pointer and a count. So if you do here, you've got compare time assert, you can see it's just two sizes of the ints. So that's what a slice is. I'm going quickly through the syntactic stuff. This is non-important. Here's the helper type stuff. So you can write type before a type to say, hey, this is definitely going to be a type. This is for the user to read more than anything. The compiler doesn't really give a damn. It'll figure it out for itself. So now, another thing, this is kind of, I've copied this idea from JAI. I've unified the declaration style, so it doesn't need any prefixes. So there's only either constant declarations, variable declarations, and declarative declarations, or whatever. I can't pronounce words. So here you go, these are all just variables. These are all constants, so you can have like value constants, you can have type that are constants, and you can have procedures which are constants. If you change these to be equaled like that, now they would be values. You can't do that to types because that doesn't make any sense. A type doesn't exist in memory. It's just something for the compiler to check. And I can just prove it, in fact. That'll still compile. that will not compile. Let's say, hey, int is not an expression. So, hey presto. I've now removed the plus plus and minus minus statement operators. I might add them back again, but I originally just had them as statement things only, so I thought they're a bit redundant. Just remove them. You can also build applications straight to as a DLL, so you just write odin build DLL and then demo.odin. Fine. And last thing for the syntax is the new vector syntax. So you define a vector like this. So it starts with square brackets vector, the number of the size, and then the number inside the type here. So there's two ways to access them. You can either access them like in an array, so you can do the index of that type. And if the count is between 1 and 4, you can actually just say .x, .y, .z, or .w to get it. So it treats like a normal vector in mathematics. And you can just, again, like any vectors, you can add them together. So if you had another vector here, so let's say u and v, I could now just do a w, and u plus v would work as well. So it's easy to use. I've explained these in the previous demos, so please check them out. They're all on the website. I'll just quickly, the Handmade Network page in the chat, there you go. So now let's go on to prefixes. This is something I only added about a week ago, in fact. So here's a type here. So the first prefix, which was originally in the first demo, I've kind of unified a lot of some of the stuff, is just thread local storage. You say, hey, declare this variable to be in thread local storage. Now this is only allowed in global scope or the file scope. So that's where that has to be. If you put this into the procedure scope, it says hey, thread local is only allowed at file scope. So that's fine. So as you most know from previous demos, I've had the using syntax. This means we're going to bring the names of these values from the prefix type into this namespace. So you can either access them as var.x or just x. That's very useful to have. The new things I'm going to show off are the immutable ones. So immutable is a little weird. So what it means is this value, the value of const, cannot be changed. So if I try and assign to it, it says cannot assign to const.x. This means because this value is kind of treated as a named R value in C++ talk. In my system, it's just a named value, as I call them. And if these would be a variable. But that's kind of how it works. So there's kind of some little things. You can also apply these prefixes to procedures and functions. So you can do here. So you can go using immutable pt this pointer type prefix type here. Yeah. You can also put a mutable pointer. So this means that the pointer itself, the value is immutable. So you can't assign to it. Let's get rid of that first. It says immutable, cannot assign to immutable. But this is a thing I'm not sure about if I should allow this or not, is if you do an indirection, so you go through a pointer or through a slice, you can assign to it. So there is nothing wrong with doing that. I'm not sure if this is what I actually want the behavior to, and if I don't, I might even completely get rid of immutability, but that's fine. The other prefix thing is the no alias. Now this is very, very, very similar to C99's restrict. This pretty much means I don't have to program in Fortran anymore or anything like that, because one of the advantages of Fortran that every Fortran programmer seems to boast is like, hey, we don't have any aliasing when it comes to pointers or anything. But C99 solved that with restrict, and I've now got no alias in here as well. So that's literally the only advantages Fortran I can think of. Yep, that's it. Goodbye. Right, sorry, it's just not to hate on Fortran. I know a lot of people still have to program it. I feel sorry for them. So now on to one of the cool features, which is what I call when statements. So here are some conditions. I made some constants. Let's say x, let's say it's 123 plus 12. Y, you divide that by 5. And then the condition is y greater than 0. Now, the when condition is very, very similar to the static preprocessor if in C or C++. But instead of being at the preprocessor level, this is actually working at the compiler level. This is semantic. So it knows if you're passing a boolean in or not. So this means it's very good. So it goes through here and it says, hey, when this condition is true, execute this piece of code here. Else execute this piece of code. The good thing about this is this piece of code will still get parsed. It will see to see, is this still like syntactically correct? So if I started just doing some gobbledygook in here, it's going to say, hey, there's a syntax error here. You've got something going wrong, but that's fine. But here we're going to say, you can see we've got, it says y is greater than 0. If I change the condition to be not, we get y is less than or equal to 0. Yeah, makes it very simple. It's also a very good way of blocking out code. So again, none of this exists, but it's completely valid syntax. And I've just gone when false. If I put this when true, hey, this now works. This is wrong code. Now, one thing I should also note is that when statements are also applied to these declarations, these special type of declarations. These are for like foreign libraries, imports, includes. And the reason why I've pasted them and not allowed to do when statements in the file scope is to prevent some problems in when you're kind of parsing or well, checking it. You get some weird graphs that you have to check and you have to figure out which order you go through, and it's a horrible nightmare of dependencies and like, hey, which thing includes which, when which order do you have to evaluate it before. And the easiest way to remove that is to add like when conditions to the end of these things here. So, and do it that way. So another example would be in my OS code. Include the OS Windows when OS is equal to Windows. That's working. You can put semicolon there, does make a difference there for some reason. And that's perfectly fine. So that's kind of why I do it. And that means it gets evaluated in the source order, the order it's in the source. And it solves a lot of problems and it makes it really fast to process. So again, here I'm talking about it's kind of like the traveling salesman's problem. It isn't exactly the traveling salesman's problem because traveling salesman's problem says there can be multiple routes just trying to find the optimal one. This can be the same thing. You're just trying to find. You're just trying to think, okay, which is the right order and which is the fastest is what I'm trying to find. I am trying to do that. I'm trying to make it fast to pass. But if I can get rid of that problem, it makes everything a lot easier. So now I was going to talk about foreign procedures. This line of code is actually quite useful. I've already added here. So this says I'm going to import a foreign system library. So this means it's not relative to this file. It's relative to whatever the system uses. It's called user32.lib. Might have heard of it if you've ever done Windows programming. And then I'm going to name it as win32_user. This is the name of the library. And again, I'll only import this when the condition is I'm on Windows. So if I'm want to store a foreign procedure, so this is like show window, I specify it's foreign, and then I have to specify the actual library it goes to. The reasoning behind this is that you won't have to it'll only include or link the libraries that you actually use. So if you include a library and it has all these system libraries you're using, it has imported there. If you don't use any of the functions that refer to it, they never get linked to it. And again, you can also see the syntax here. So if you want to specify a different name to the procedure, but you want to show where the library name is here, you can do that as well. You can just put a string at the end. It's quite useful. And again, this would be useful if I had my own custom linker, because I wouldn't have to actually search across all the linked libraries. I can just say, hey, it's in this one here, grab it please, and so on and so forth. So I very much like that. If you want to see more examples of that, please do go into the sys windows file, which is my win32 thing. You see all these lovely system libraries here, and we're going through here. You can see like here's some types with different calling conventions. That's the C calling convention. So here's some procedures here, and they say these are in the kernel 32. That's user 32, and you can see if you don't use them, they don't get linked. So now it's gone to these special expressions, which I kind of wanted to call them. So I've been experimenting this. This is not final. It's just an experiment. And what it is I have block expressions. So this is a block of code which is treated as an expression. So some modern languages have this and such, where everything's an expression or whatever, like Rust and such. But mine's a little bit weirder, and I will say this, I've made it quite explicit that if you're using a block expression, they have to have a value, and they must end in like this give statement. So this is very similar to like a return statement for a procedure, but this is saying, hey, give this value to this block. So each block, you can still do any amount of statements in here. And is the stream all right? Sorry. Apparently someone's complaining about OBS. It should be fine. I've not dropped any frames or anything. No. So I'm just checking. So you can do any statements within this code. So you can just treat it like a block of code. This would be very, very similar into like when you're doing in C. So you may have had like int that, and say condition equals, let's say 1, 2, 3, else 3, 2, 1. The difference between this is this has to be a condition, an expression, that has to be an expression, and that has to be an expression. In here, you can just do a bunch of code and it works. In something like Python, you'd have to do like something for this condition, in, while, whatever, and it would be backwards. Here you're just writing plain old code. And it's very nice. Sorry, someone's asked a question, does ODNS get set by the compiler? Yes, there are a bunch of variables, only I think half a dozen, that are built into the computer, like the OS, the platform, the architecture, the Edianness, and something else, and they're just built in. They can just call them, they're just constants. That's all right. The other thing I thought is, well, okay, from block expressions, I'm going to have if expressions as well, and they still have to have this GIF inside this. So if this x is less than 5, we're going to give x away. Else we're going to give 1, 2, 3. And just to prove that, I'm just going to go print line y, and I'm going to do x and y there. And whereas this should be whatever x is. Whereabouts is this? I'm going to just also do hello. This is my Hello World version that I've been using for the past, I don't know, 10 years. Hello. So we've got 0 and 0, which might be correct. It's correct, I think. Yep. Oh well. Let's just prove that. Yeah, that's correct. Just doubly checking that. So that's quite useful to have. So give is, it'll just give this expression to this block. That's all it is. That's it. It's kind of like a return in a procedure, but it's a give for this block. I had to give a name. I couldn't use return. I couldn't use yield. It just didn't make any sense. Again, none of this is final. It's just an idea. So let's go on to the next thing, which is I kind of find very interesting, and I'm pretty proud of it. And one of the things I actually did, I only implemented last night, and you'll see why. So in the previous languages, I've had these C-style for loops. These are just what you do with for loops. You'd have like condition, here's that initial statement, a condition, and then the post statement. You could also get rid of the post statement, that's perfectly fine. And you could also get rid of the initial statement, and that would be fine as well. And just to make syntax a bit clearer, you can completely get rid of all of the semicolons, and you can just treat this as a while loop. And if you can completely get rid of the condition, you've got a forever loop, is the best way. Because in C, it would kind of look like that, but I've got no braces, and because those semicolons are redundant, there you go. So that's kind of nice to have. All the loops are just for loops. Now, I actually removed this when I was implementing the next feature, and I've just added it back because I found a way to get it back. Most of the time, you don't really need a C-style for loop. You only need it if you need to do complicated stuff, or some stuff that's easier to do with that style. Most of the time, you just want to iterate something and just get on with it. So what I've done is added some nice little syntactic sugar and added these kind of ranges. So this is a kind of range statement. So for I, which is the value, in this range of values from 0 to 123, exclusive, so 0 to 1, 2, 3, 4, all the way to 1, 2, 2, to go through these values. And this is dot dot less than. And it's quite simple. It kind of makes more sense to read that as well. If you want an inclusive range, so this is half open, this is half closed, this will be open. you just do 3 dots, so it's an ellipsis. Very nice. So this just gets the value from this range, what the iteration is. Say you want to actually get the index that you've iterated from, you need to put another value on the end. So you go val, comma, index in this range. So if you print it, it'll be here, it goes 12, 13, 14, 15 for the values, and then for the index it'll be 0, 1, 2, and 3. Very good. So now you've got 2 variables iterated across. You could do the same thing in 4, but this is shorter and it's less error prone, for me at least, and hopefully other people. Now, again, because I allowed not just these ranges, you can actually pass variables to it. So here's an array, and it's got some primes up to 19. You can just pass that array in, so get p in primes, and it'll print all the prime numbers for me. So you can see there's all the lovely prime numbers, 2, 3, 4, 5, 6, 2, 3, 5, 7, 11, 13, 17, 19. And there you go, it's done it for me. You can also take pointers to arrays, or slices, or strings, and they're all allowed. So those are all iterable. They're the default types that are iterable. Vectors aren't iterable at the moment. That's because LLVM, not because of me. LLVM stores vectors very weirdly, and I'm going to get rid of that and just do it my own way. So screw LLVM. But yes, you can also ignore the values. So if you just want to go underscore, you can ignore it. Now, if you did this, this wouldn't actually be valid syntax. This would actually say, hey, this is not a Boolean value. And it would say, hey, just to prove it, say this is a non-Boolean condition for the for statement. So if you want to ignore the value, put an underscore there. That's the same notation elsewhere to ignore values. So when you iterate across a string, it's a little bit different compared to all the other stuff. Strings are assumed to be UTF-8 in this language because UTF-8 is probably the best format for strings you can have. It's the most compact and it's the most usable. It doesn't worry about endianness, or it doesn't worry about anything else, and it's kind of universal. So let's have a name. This says hello world, and I think this is in it's in Chinese, isn't it? Yes. And it just says hello world. Yeah. And to prove it, there you go. There's the printing of hello world. So when we iterate across this string and we get the runes from it, a rune is a Unicode code point. To prove this is a rune, I just say check the value. Is the type of R equal to a rune? Yeah, this is true. And then we print and we pass the rune to it as we go through. And you can see it gets every single rune and prints them. This would be exactly equivalent to if I did this standard for loop here. So you got I in size 0, iterate until you get to the count, and then iterate with the size every here. So you just decode the rune, which is in the UTF-8 standard library, give me the rune and the size of the rune, print it out, and then it go like that. This is much nicer, and a lot of the time you do want to actually do this. You just want to get the runes out. If you want to do some other things with it, like special like iteration styles, maybe this is probably a better style for you and it's much clearer. I've been thinking about implementing iterators into the language, but I just cannot think of a good way of doing them, because the semantics will just be a bit weird. And if anyone's got some good suggestions, if I should implement iterators into the language, like one the users can generate, or even something else, please do. I would like it to mesh with the language and be very, very simple. So now let's go on to the thing that took me a while, and I wasn't even sure if I should even add it to the language, which is procedure overloading. Now, originally I still want this to be a better C, but as I've been thinking it through, if I want to have some basic form of it's called ad hoc polymorphism, or like some form of like doing basic generics, I'm going to need some form of procedure overloading, because it does help a lot, especially when you're doing maths. But in many cases, I don't need it. It's mainly just for mathematics, which solves a lot. But again, if you're doing a lot of maths, you really do want it. So let's just start with a basic example. I've got 2 constants here. This is a floating point constant, and this is just a number constant. Remember why I've just said number. So then I've got 3 procedures called foo. One that takes 0 arguments, one takes an int, and one takes an F64. Yeah? So we can just call through. So we call foo nothing, and we can get it works. So what I'm going to do, just to make things a little bit more clearer, is cancel the syntax and just call procedure overloading. Here we go. Yeah. Procedure overloading, there we go. So the first line gets called 0 arguments. This gets called F64, and then this one, which I've casted the number to an int, goes to int arg, that one. Great. Now I wonder why I haven't specified this. Now, you can probably read the comment as well, but I've said, hey, an ambiguous call to foo. Now, I've not used the same rules as C or C++ for procedure overloading or many other languages because I don't particularly like them. So the way this works for procedure overloading, the rules are quite simple. You search in the current scope for, if you find the function, if it's a function you find, search in the current scope for any other that's been overloaded. Then you compare the arguments to it to see if it works. If there's any arguments that have kind of like the best same score, then it's ambiguous. So this number, because this is just a number, it hasn't got any type specified to this constant, you could convert this to either an int or an F64, and it would be perfectly valid. So it says, hey, this is ambiguous. You cannot do it. So please cast it to the correct type, this is what it's saying. So that's one thing. I've again got more foos going on here. I've got two different pointer types. So one is a pointer to an I32, and I've got another with a different ending there, and I've also got a pointer to a raw pointer. Let's take some values, so an A, B, and C. And the first one here, it's passing an A, and it's going to take this one here. Even though it could implicitly cast to the raw pointer, this is like C++ with its void star, it's better, the score is better to go to that one. So the first one, it goes to here. If I cast this to be a raw pointer, it'll actually say, hey, uses bad value, and there's a compiler bug I've just found. Yay! Isn't that great? I didn't realise that. I know where the bug is initially. I can fix that. For B, this is an F32. There is no function that takes in a pointer to an F32, so it's going to go to the raw pointer one. And C is a raw pointer, so it's going to go there. Now, if I pass nil, which is the 0 constant for a few types, it's going to be an ambiguous call again. It says, I don't know which pointer type do you mean. So there's one of the answers. So it says it's ambiguous and all that sort of stuff. This demo is quite short because I've tried to keep it short and compact compared to the other demos. Sorry, I'm going off on a tangent here. But yeah, this is ambiguous because it doesn't know which pointer to go to. If I just cast this to be a raw pointer, it'll work perfectly fine. If I cast this to be an I32, it'll work perfectly fine. And that's a bug. Why is I know that's a bug because it's assuming there's actually a thing to dereference. But yeah, there we go. And the other thing, which is actually I got pretty impressed to do it, is actually it knows which foo to choose. So if I had to find a variable called f, and it takes the signature of proc, you can pass this foo into f, and then you can call it. It knows which one to choose. So that's really quite useful to have. So you can just pass procedures around. They are first class. To a point, procedures are first class. I don't have closures or anything like that, but whatever. If you want to see more examples of this, some real world examples of this, oh God, I'm just repeating my words now, is in math.odin. So if you want to go look here, you've got square root and sines and cosines and such. It's using the LOVM core library. It's tans here, you got lerp, bit reverse, bit byte swap, fmult, sine, whatever. These are all overloaded, and they're very useful concepts to have, in my opinion, to overload. Like dot is a very useful thing. I do a lot in vector math. There's cross, mag, norm 0 if you want to give it a 0 value instead of like 1. And again, muls for multiplying for different things. Just overloading is very useful. And an atomic is another example of this. Load and store. Again, this is a crap atomic library. I actually haven't done it. I just wanted to see what it would look like in this language. And just say, hey, the type will be done correctly for you. You don't have to worry. You just have to like load and store. You don't have to say load 32. If you're a C program, you may say that's actually better and clearer to do. And you might be right. Again, I just want to have the architecture built into the language so I can have procedure overloading. Like if I want to remove it, it's about one line to remove, because I'll just say if 0 and done. But I want it there to work. If anyone wants to know more about the rules and procedures, they're actually really, like, overloading. It's really simple. I made it that way, unlike C++, which is complicated because C++ namespaces are complicated. But my namespaces and scope rules are very simple. So these rules are going to be very, very simple. So that's pretty much all I wanted to do for this demo. There's more back-end work I've done actually, but I've just kind of trying to condense this to this example. So if anyone's got any questions, please ask. And fire away. I'm going to see this questions that's already gone on. Yes, someone was asking about the expressions. Yes, this is kind of like in GNU C. If you did this, that actually works in this language as well because it's just an expression. But that's GNU C syntax for a block expression. Killjack saying without interfaces, traits, or closures or the like, iterators become iffy. Yeah, they probably do. I've seen how JAI does them, but JAI's namespacing is iffy as well. I'm not bad. I just don't particularly like it. I have kind of each file is a namespace. For him, everything is in the global namespace when you do it. Well, it kind of is, and how he searches for things is a bit weird. So there's a lot of implicit stuff going on with iterators. I probably want to make them explicit, but also I don't even know how I'd actually do them. Maybe a custom for loop would be better, or even better, macros of sorts. Okay, so I've got a question from Sean. It says, do you have a VM, want to add scripting language to a game? Actually, I need to write a VM for this because I want to do compile time execution. So I actually need to write one, I'm going to post a question in a bit for you guys to actually answer the reason. I really like this language again, and I think you'll actually like it as well, Sean. It's pretty simple as well. The compiler itself, I've designed the language so you can actually implement it in less than 20,000 lines. I think minus some of the LLVM crap, I think it's about 19,000 lines. It's not big at all. It's tiny in my opinion, and it's all done in C. C99, absolutely great. Someone's question. If you have a float and cast it to an integer, how does it round? It's going to have the same rules as C. So if it's a positive, it's going to round down. If it's below, it's going to round up, whatever. That way, it's going to do it that way. That's from this drunk Dane, Mikhail. Mikkel, I don't know how to pronounce your name. I'll never be able to pronounce your name. But yeah, actually, one other thing I should also note is with numbers, if you try and cast this to be an int, so I'm going to say that's an int there, it's going to say, hey, this is truncated to an int. This is not allowed. This is a float number. You can't turn that into an int because it's a constant. I don't want those errors popping away. If you want to turn that into an integer, store it in a variable and cast it. Eventually the compiler should be able to optimize that out if you have a problem, but there you go. Where's some of the questions I've just seen? Sorry, I'm just looking through. Is that about it? How does LLVM round for the compiled integers? To be honest with you, I honestly just think it's the same as C rules, but I can doubly check for you. I've got the code written somewhere. Going to IR, which is my little code here. You can see the implementation. Great. Where is it? It'll be in emit conversion, which is there. So we're going from an integer to a float, aren't we? So integer, float to integer, here we go. And float to integer. So source is float going to an integer. It'll be this. This is the function they use. It's the LLVM float to SI or float to UI, whatever it is. So just look at the documentation, see exactly what he does. I don't think it's going to be anything different from C. What happens? Okay, in the for loop, if you only have one semicolon. So let's go to loops. Here, do you mean like if I did one semicolon, it's going to say is a syntax error. You need either no semicolons, two semicolons. So you kind of need to say, hey, there's initial expression, because when I'm parsing, the way I'm parsing is I check for a statement, and if there's a semicolon, I say, okay, now that becomes the initial expression. I check for a thing in the middle, so the condition, and then another semicolon to the post. That's what I do. If I don't see any semicolons, I turn this statement to an expression, unless that statement is the in stuff. That's how I've kind of merged them all. So that works that way. But there you go. So yeah, I kind of like that the only loop in this language is for. I know it sounds a little bit weird, but I think it's quite nice, and it removes a lot of the nonsense. I don't particularly need a do while, because you can emulate a do while with just a for loop. You can even go, in my language, you can say defer, you can say if condition break, that is perfectly fine, and that would act as a do while loop. So yeah, again, I kind of like, this is kind of one of the things I'm actually kind of happy about, is that I've got for loops to work correctly, and implicit and also implicit strings. This is working. This is, I only actually pretty much did this last night, the unification of it all, because originally, if you look in the previous demos and stuff, I had while loops as well as for loops and range loops and all whatever. Another question: can you make the mistake in the for loop where you have an assignment instead of a comparison? No. Statements in C, like assignments, are expressions. In this language, they are just statements. So A equals B is just a statement. If I did this here, so 1 equals 2, it's a syntax error. This is not a Boolean expression. This is a simple statement, it says. If I said 1 equals 2, it will be fine. It will not have that bug, because this cannot become, that is not an expression. Hopefully that makes it stuff. Is that the last of the questions? Because I'm going to give you guys a question now. In fact, it's going to be a poll. So, which feature should I implement next in Odin? Because I know there's one person who wants a particular feature, and that'll be Sean McGrath, who wants a VM, which will be the compile time execution one. I know some people want the macros so they can implement logging. Some people want the debug information so they can pretty much just put this into Visual Studio and actually get rid of C and just debug in this language, and that'll be fine. I know some people who just want other things as well, like inline assembly, so they can build the standard library stuff. So do whatever. With semantic macros, I probably definitely don't need iterators, because you can just create a macro to generate the code for what you need. Compiled execution would be great, because you can actually mix that with the macros and do loads of other clever stuff. Yeah, there's just, please vote on this. There's a link in the description in LLVM. You can even vote here. And I'm just going to see these, we'll see them live and see what we're getting. Oh, we've got a few votes already. Oh, they're going up and down. Let the horses grace. Go, 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 go. Some compile time execution seems to be the top one. Come on, debug information, you're falling behind. Come on. Come on, let's get some more. Let's get up to 20 votes. Come on, 20 votes. More, maybe more. What is the status of compile time execution? Yes, sorry. I was asking John actually how his system works, because I was thinking it was really complicated, I thought originally. And then I realised, oh wait, he limits a lot of it. And yeah, I found out, and actually compile time execution is doable and actually pretty easy to implement if I use his structure, which means, what is it? calling conventions have to be different. So like a certain thing is a certain calling convention. So all loading functions have a certain calling convention compared to C ones or the standard or fast or whatever. They'll have different calling conventions. You can't intermingle them. If you cast them, you're doing bad stuff, and you serve the price if something goes wrong, in my opinion. The second thing is you can restrict some types. For instance, you can't output variables from run which have a pointer backing to them. So it's either a pointer or a slice or something like that. And you cannot do that. So because the memory of the virtual machine is a different memory space to the compiled memory space. So if you have pointers pointed to memory, it won't make any sense. So don't do that, is the short is. So disable those types to be executed from the compiled execution. And then there was one other rule which I forgot as well. The other problem is just interfacing with C code. Make sure the C code using calling conventions you know about. And I think that's about it for the compiled execution. So it looks like compiled execution is winning. Then I've got to implement debug information, then semantic macros, then inline assembly, and then documentation generator. I think that's literally going to be the order I'm going to implement stuff in. It should be great. Go semantic inline compile time debug information generators. Yeah. Yeah, sorry. I actually have a professional microphone. As some of you might know, I used to be a DJ. I actually was a real life DJ. So I know how to use it on a microphone and stuff. And I am a musician, so I have to know how to set singing microphones for people as well. So, but that's a different thing. I've done a lot of weird things in my life. Yeah. So it looks like compiled execution is the next feature I've got to implement. So stay tuned for the next demo, because that also is going to make me have my own VM, which should be able to run the thing in. So, yay. So someone's just tagged me. Oh, I'm so sorry, Mr. Forrest and Mr. Drunk Dane. Sorry about the debug information, but that will be the next feature I'll implement after that. Then it's semantic macros, then inline assembly or documentation generator. If there's any others, please specify. Honestly, if there's any other ideas I haven't come across yet, please do it. What's my opinion on procs attached to struct? You mean like methods? I don't particularly like them. I do find that they're useful, but it's mainly shorthand is the best thing. They're not really... What's the best way? If I have them in the language, I'm going to head down the rabbit hole. If I have them, you've got to take advantage of them. So something like Rust has traits. They take advantage that these types have methods. Go has methods. They take advantage, so they have interfaces and such. If you just have methods like in C, C++, you're not taking advantage of them. Yes, you can do like the inheritance model and stuff and overloading, but usually I can do that in C and actually even be more flexible of doing it that way. So I don't see the advantage of that. Really, it is just a shorthand. Like many people have an init method or a destroy method on their things or something. That's about it. I don't particularly like any of like that. Yes, there's one, yes. Okay, so I think I might, unless anyone's got any other questions going. Oh, where's the attribute stuff? Yes, sorry, that reminds me. So Mikkel actually, or this Drunk Dane in the chat, or Hjordsju, which I don't pronounce, but again, can't pronounce Danish. It's a wonderful language, I expect. I'm awful. I can't even speak English half the time. So yeah, yes, he was as I suggested, I had some attribute stuff like C# and stuff like that, where you can give some extra information for the user, saying, hey, this is some debug information, this is whatever, this is or you can give stuff for to do in probably the part-time execution stuff. You can say, hey, do optimize this here, do whatever like that. It's very, very useful to have. But I'm not sure if it's a good thing, because again, if you have it, you want to take advantage of it and you want to kind of go down that rabbit hole. Again, I'm not sure if it's a good idea or not. Again, it's on the table still. It's still aren't in my notebook. I've got loads of ideas in my notebook for this damn language. Like, I've still got some to-dos. Oh yeah, I forgot to implement that. Yeah, one of my to-dos is make a big numbers library for the constant system. At the moment, I'm just relying on 64 bits of goodness. I want to treat numbers as if they were numbers, so you could do a Google divided by a Google minus 1, and that would still work. So, I think that should be enough for tonight's stream. Thank you all for watching, and thank you for voting on this. If you haven't voted, please do it before I close the stream. Hey, debug information could win out. Come on, debug information. It's a lovely colour of that purple. But yes. I know, yeah. So, yeah, so the next demo, hopefully we'll have compile-time execution, have a VM, and make Sean McGrath happy with his scripting language in his game. Also, if any of you don't know Sean McGrath, check out his programming streams on twitch.tv/SSSMcGrath. They'll be in the graph in there, and in the chat in there, and he's making a MOBA. And he's doing it all from scratch as well. It's absolutely fun stream. If you don't mind swearing or very foul language, I love that stuff. I fucking swear all the time, but I'm trying not to swear tonight, even though I've just done. Please go watch that as well. And for everyone else who's on the Handmade Network, please check them out. They're an absolutely great community. The Odin Handmade Network page is here, so it's odin.handmade.network. If you've got any questions or ideas, you can post on the forums. It's absolutely lovely. Or if you've got any other projects you want to talk about on the Handmade Network, just go to the Handmade Network there, and they've got some absolutely great projects here. Some of them that I actually already use most days. So I'm just going to do a plug here for this Handmade Heroes, and most of you probably already know. 4Coder, which is an absolutely great text editor if you want to replace Emacs. MotionBox, I actually use this for most of my video viewing now. For YouTube, when I've got big playlists, it'll actually just remember where I've gone to. It's one of the best features about it. Papaya is a nice little image editor. I don't do much image editing, so it's not good. Raylib seems very good if you want to learn about video games. STB libraries, very good. Odin, yeah, check that out. It's a really good language. There's O-Time, which is done by this drunk Dane. He's been writing C-Time, which was Casey Moritori's like timing program to check how things works, and he's rewriting that in Odin. So check that out. It's pretty good so far, and it works at least. So it shows the language is good. Some other good stuff in here, again, some games and stuff. I mean, I'm just going through this quickly. C toys, so you can treat C as if it's like a scripting language. Tweet with C is very good. Cascades are quite pretty and stuff. There's loads on here. I'm sorry, I'm skipping over loads. My libraries for GB, whatever. Handmade Math is good. Milton, I actually use this all the time. You can see it on the top here. It's an absolutely great drawing program if you want an infinite whiteboard. Again, just please check them out if you haven't done so, and go there. Oh, sorry, Will, if you've missed this will be on my YouTube channel, along with all of the other demos. My YouTube channel is YouTube Ginger Games. There we go, it'll be there, and they'll all be on there. This needs to be uploaded next, so great. So thank you all for watching, and please post suggestions and questions, and please post issues on the bug reports as well if you find a bug. So thank you very much for watching, and stay tuned for the next one.